competing standards. The newer standard is the more elegant solution. The older standard is the CHAdeMO standard. It's the one that's out here. There's going to be a bit of a toing and froing about which one's going to prevail, and that'll happen over the next, say, 10 years. And so when you're choosing your car, which fast charger solution, you'll probably need a CHAdeMO one for Australia, but it'll probably change in the next 15 years. So that's sort of all early market stuff. This was a car that was at the EVS 27. So Qualcomm make a lot of, basically a lot of chips for mobile phones. I don't know who is familiar with Qualcomm as a company. They're enormous, basically, and they make a lot of stuff, a lot of electrical components, and they've made a heavy bet on induction charging. I'm not sure. Induction charging, who's got a rechargeable toothbrush? Anyone? I've got one. It's great. Really much more effective than normal toothbrushes if you're not on it. But anyway, the technology that's in a rechargeable toothbrush is exactly the same. It works through the electromagnetic fields of the coils that are in the toothbrush and the holder, and they interact and transfer charge across what is otherwise space, you could say, through the plastic housing, or in fact between the car and the ground. So Qualcomm are pushing this really hard. It could be a breakthrough technology for public charging in particular, because it gets rid of the cable out of the public space, and so therefore there's less things to vandalise, less tripping hazards, which are a genuine risk for publicly funded equipment, and so therefore you'll see it get pushed very hard. So Qualcomm have got this car in Formula E. This will be on this year. Anyone familiar with this? Anyway, it's going to be a new class of motor racing, and they're looking to push this pretty hard, but there are some limitations with it. It's really expensive. You've got to install underground cabling right up to the charging outlet. You've got to get the separation distances right. It's basically, and it's proprietary, which is another problem. So whether this comes off or not, I'm not quite sure, but you can get a Nissan Leaf already with an induction charging pad on it. That means that you don't have to get out of your car to be able to plug it in. It can just start charging on the pad. Some of the applications for this you'll see are in public bus systems, where they have a very reliable journey. They'll have basically, who had slot cars when they were growing up? I did. I feel like I'm telling my life story here with my toothbrush and my slot car adventures and things like that. The track that was along the roads, they have that already now for public buses, and that allows them to charge as they are driving around on the road using these induction charging technologies. So that's an early use case that looks quite plausible. It removes the need to have an enormous battery on the bus, which increases the amount of people you can carry on it, decreases the cost of the bus. So there's a lot of reasons why it would work, perhaps not so much the car. Anyway, I tend to find there's a bit of an overlap between people who are interested in electricity and people who are interested in electric vehicles, and so recently I wrote a white paper on the topic of electric vehicles as grid support. So again, if you're looking for some bedtime reading, then that's an option. Go and have a look at that. But I'm going to talk about the relationship of electric vehicles to the grid, because that's something that people are quite captivated by, I tend to find. This diagram here, it's a very simplified schematic of this sort of smart grid of the future, where there's a lot of distributed energy resources. The independent system operator, who is called AEMO in Australia, they schedule in the resources, and there's interactions. And here, the two-way arrows denote vehicles as being both a demand on the grid, in terms of they take electricity for charging, and they supply it back into it. That's the vehicle-to-grid division. Now, obviously, that sounds absolutely brilliant. Wow, how amazing. We could have our parked cars, which are basically useless otherwise, taking up space, actually provide grid support, possibly provide you with some revenue. Oh my God, this future sounds great. However, it's not going to unfold that way, and the reason is because the electricity market rules are very complicated and very slow to change, and the way in which vehicles will be integrated into the grid will be as a load on the grid initially, but not so much as a source of energy. And that's because the competitive position of the vehicles relative to stationary storage solutions is not that good. So they're not available enough and not available reliably, and they're not high enough capacity. So without getting too bogged down on it, if you want to know more about the early use case, could be things like ancillary services, if those who know anything about the grid operations and the markets out there. basically it means you're providing stability to the grid. Even in that application, there are better answers than electric vehicles, so I don't think that's going to fly. Alternatively, let's just say you live in a part of the world where you're prone to tsunamis, and you could occasionally, predictably, be at a loss for power. Your ability to charge your mobile phone, if you have an electric vehicle, is a very near-term prospect. So Mitsubishi already in Japan sell this power box here, and basically this just allows charge to be extracted from the vehicle and some outlets here, and rather than have to set up a card table with a little Jenny next to it, you can have this little box there and have people's mobile phones plugged in and use it for other very small loads, and that can work. So a Nissan Leaf is 24 kilowatt hour battery resource. The average American home uses 30 kilowatt hours a day, so that's not going to last that long, but if it's an emergency scenario, Japanese homes are very energy efficient, for instance, and so they could get maybe 2 to 3 days worth of power from their electric car, and of course possibly used as transport as an alternate use. So that's highly plausible. Right now you could do that, and that's something which, particularly those who out there who've got the ability to wire these things up on their own cars, that's something which you might find useful when disaster strikes. A more mainstream solution is going to arise through the convergence of the connected home and what could be called net zero homes. So I'm going to explore both those topics. Who here's got solar cells on their house? Perhaps about maybe 30%, let's just say generously. So the coincidence of interest in electric vehicles and solar energy is very high. So the demographics overlap quite closely. Those who tends to be in Australia, obviously there's 10% of households with solar, so that's much higher than electric vehicles. But the trial I ran, there was a massive overrepresentation of people who had solar power on their homes who were interested in electric vehicles, and that applies worldwide. What you're seeing in homes is more and more appliances are becoming connected, and so this rise of the smart home or the connected home, you're getting appliances such as the early use cases actually clothes dryers, for instance. Smart thermostats. Who's familiar with the Nest thermostat? Yeah, that's more in the US because they've got central heating, and thermostat controlled heating. Fridges, perhaps less likely, that could tell you that you're running out of beer or some critical scenario like that. But alternatively, it might run more efficiently in certain circumstances. These things are starting to become interconnected through what's called the Internet of Things. And Internet of Things is converging around the home in the form of connected home hubs. So iiNet is the early mover in Australia. They have a hub that used to be just your internet router, then it became your VoIP phone, and now it's starting to get your entertainment converge, and it'll also do energy management, and that's going to continue to expand. And so you'll have the ability to manage your devices through these connected home hubs. This is happening right now. There is a high availability of mainstream solutions in the US from very large companies like Verizon, Lowe's, who are a very large retailer, and they can all supply you with these hubs and connect their devices to it. What's going to happen is there will be a convergence between that and what you could call the net zero home, which is where you've got not so much of a feed-in tariff for your solar power, and you've got more of an incentive to basically try and use the power you generate. That will allow you to minimise your electricity costs and obviously maximise the benefits realisation from your solar power investment. But you don't want to have to obviously look outside, sun's shining, go inside, switch all your stuff on, cloud comes over, quick, switch it all off again. That's not going to work. That's not a very elegant solution. So what instead you'll have is you'll have these central controllers where they sense when you're generating electricity, and they'll run your home preferentially during those times to align the supply and demand of your home. And that will minimise your electricity costs, allow you to make progress towards a net zero energy consumption lifestyle from the grid, and your electric vehicle will become highly integrated into that. So this is likely to happen over the next, say, 5 to 10 years, as you see it be driven by the convergence between the people who own that and the people who would like to own that. Both these things are growing rapidly in the States. So in the US, they have less than 1% solar uptake at the moment. That's changing rapidly. They have much higher concentration of electric vehicles in particularly parts of California and alike. So those markets are going to drive the technology companies to bring out these solutions, and you'll see that be more and more visible.
We already have some sort of that at the moment. It's just a lot of key approaches where any power you generate from your house, make sure the electricity meter turn backwards. So it is in effect reducing your electricity costs, but it's not automatic. So that once the networks get on board, then they'll be able to do it via their network communications.
They would, except they won't. That's my prediction. My prediction will be that they'll stick with the higher value, lower transaction cost applications, which is commercial industrial. They won't invest a lot, particularly in Australia. They won't do a lot of work at all around what's called demand response, where they have relationships with individual homeowners. The retailers, for those who don't know, the retailers more or less lose money on solar power customers, so they're not interested in even attracting the business. They have to, by law, provide retail power options, but they're not going to invest anything in solutions which are better designed for those people with solar power. It's going to instead be driven by other technology providers. So the people who, so you'll see, maybe some of the solar power providers in Australia may evolve and become more sophisticated and integrate these solutions. Alternatively, it might come from companies such as GE and the like. And it'll probably come. There's a challenge between the American market and here because they run 110 volt and we run 240. But because it's independent, once it's happening behind your electricity meter, then it's really a consumer-driven decision. It's no longer about what's the rules for connection and your feed-in tariff and all that sort of stuff. If it's behind the electricity meter, you can do it yourself, and as in it's your decision. You don't have to apply for and get an approval or anything like that. And it's just about basically trying to realise this net zero home, and it's a lifestyle decision. My Energy lifestyle tells the story here. Lifestyle. So I would like that lifestyle myself. I'm not sure how much I would pay for it, but it's becoming more attainable, particularly as the vehicle costs are coming down and these smart home technologies are evolving. So, to save you the trouble of trying to remember everything I've said, I've decided that I've basically said 6 things. I've said that public charging infrastructure and EV adoption go hand in hand. So that's been proven around the world. They have already found the evidence of that, and that means that governments who are looking to promote adoption of electric vehicles will look for effective policies to be able to promote the adoption of public charging infrastructure. Quick or fast charging, it's sometimes called, is a key enabler and is evolving rapidly. So what you're seeing is that that's the most efficient way of governments to be able to put out this public charging infrastructure. It's probably the most likely solution that you would use, more likely than just shopping centre, because you're not probably going to be there for long enough for it to be worthwhile. But there is a lot of change still afoot in that technology space, so you'll see a lot of change there. Induction charging I sort of covered off. I won't emphasise that because it's not a big deal. The vehicle-to-grid technology stuff, it does get a lot of play. People are really interested in the idea of how electric vehicles will support the grid, but it will be constrained by electricity market rules. Emergency backup right now, and you will see this convergence between the smart home and the net zero home. I'm happy to take questions, or alternatively, you have your freedom.
Is there any standard on the type of connector
in Australia, or
for fast charging or the ordinary charging? At least there's some sort of standard.
There's multiple standards. Is the both the answer and the problem, you could say. So the reasons for that is because electricity networks themselves have very different characteristics around the world, and that's because they've formed organically. So history of electricity networks is that they formed at a precinct level, and they grew out, and then they became interconnected through transmission lines. What that's meant is that you have a lot of different solutions out there that were conceived in isolation, and they've just basically continued to evolve, and now it's like, wow, it's just this patchwork quilt of different solutions out there. That means that the charging standard is different for different markets. There's communication standards which sit in parallel with that. In Australia, it will be market-driven outcome, and that means that it'll be the SAE J1772 standard. It because that'll be what the cars are that come in. And the government's not interested in doing anything about standardising it itself. It will just recognise them both and allow the market to decide. And the fast charger, CHAdeMO has the advantage because it's got the equipment on the ground, but the SAE combo connector is a more elegant solution because you can use one connector for both your standard and your fast charging. And the car companies would prefer that. It's less components, therefore it's less cost in the car. So I don't know what's going to happen on the fast charger, but CHAdeMO has got the advantage on the ground.
I just make a comment on that last point. The iMove, the Mitsubishi iMove, has the CHAdeMO and the 1772 connector. So that's one elegant solution. The question I have is, have you had anything to do with magnetic resonance induction charging? Where you have a magnetic coupling rather than an normal electrical induction charging?
No, but I'd say that was still, laboratory research type applications.
Well,
I don't know.
There is actually one there's not one available commercially, but I know there is one being trialled in America on an iMove. And the electricity company, Electricity, are actually the people who are involved. I just sort of know come across.
I haven't, but there are things. What's happening is the market is evolving, and what you're seeing is the Californian market in particular is going from early market to more mainstream market. So people who are just not early adopters of technologies, but just normal people, increasingly considering buying an electric car. What Californians have done is they've legislated to require interoperability across public charging stations, which sort of means that these alternate solutions are going to basically miss the boat. That's my prediction. So I'm currently working for a commercial company. We have to make investment decisions based upon what we think is going to happen. Whilst interesting, these alternate solutions, I don't think that's what's going to happen.
There are some big advantages with I don't know much about it, but the big advantage of magnetic is there's nothing in between the two coils, for instance, except a magnetic field, which we're totally immune to.
Well, interestingly enough, there could be your cat wandering between these things, and that's where Qualcomm have had to design like shut-offs to be able to stop your cat from being vaporised or teleported to another dimension or whatever the hell happens to it. So
that's what I'm saying. The advantage of magnetic over electrical, you have a strong electrical field.
Yeah.
With the magnetic induction, you don't have anything there that's apart.
Well, this may be true, but I think it may be
unless you've got a magnetic foot or something.
Yeah, well, that's right. I mean, I must admit my magnetic feet are serving me well these days, but it's possible. It's possible, and there are a lot of technically possible solutions out there. But I suppose the discussion we're having is the difference between technical possibility and actual financial market viability. And I think because of the issues to do with, because charging is a classic chicken and egg problem. You've got the car and you've got the charging outlet, and they've got to be the same. It's an interface problem. So unless there's a car company getting on board, pushing this really hard, then it's not going anywhere. That's basically my prediction. So yeah, can be tested and proven. They may patent it, but it's got to be interoperable, and proprietary solutions don't lend themselves to interoperability unless you're Apple. Gentleman there, and then there, and then up there.
Does it cost to install a fast charging station?
A fast charging station, the cost of the station has actually come down a lot. So let's just take, how much am I allowed to say about the Swinburne installation? Yeah, I'll keep going. Righto. So that charging station, the hardware was worth 45 grand. The installation cost, so this is Australian dollars 2013. The installation cost, it's highly variable, and it's because it depends. We caught that site at a point when they were doing redevelopment of the site, and so that minimised the cost. It was a bit hard to pick out because they were already doing trenching and things like that, so it's sort of hard to tell what was specifically for the charging station versus stuff they were doing anyway. But minimum 20 grand, maximum 90. Really, and that's, so if you've got a greenfield site, great. You could probably do as part of the original building construction. You might get out of it, the charging station costs are coming right down. I think you can get a Nissan charging you for about 10 grand. But you'll do at least double that in terms of the installation cost. And for a brownfield site, you're going to drop 150 grand prospectively. So that's hard to make back when people aren't using them, and you can only charge them $10 a pop. So it's a lot of money. So that's where it's challenging.
What's the power output of the 10,000 watt?
25 kilowatt. Yeah. So sorry, I'll just gentlemen, and then that lady up there, and then this gentleman. Sorry.
Okay. In 2 years' time, I lose my high subsidy for excess power that I'm generating.
Yeah.
I want to use it to charge an electric vehicle.
Mm-hmm.
There are no electric vehicles in my price range here at the moment.
Mm-hmm.
There is the Prius C hybrid is in my price range, but it's not plug-in. Can I solve that problem fairly readily, or have I got to wait for the manufacturers to do something?
Well, you can, but there are complications with this, of course. So inevitably there will be conversion kits, not so much for the current generation Prius, because the older generation Prius was sold at a time when there was no plug-in Prius available. Now there is one. Basically, if I had to be honest, if you're going to own the car until it dies, or you do, whichever first, then great, go for it. But if you think you're going to sell that car after your ownership experience and get some resale on it, never, ever convert it. It's not going to, you'll never get a dime for it, basically. It'll be your hobby.
It's actually the external charging infrastructure that I'm interested in, rather than modifying the car.
If it's a converted car, I don't know who here has a converted car.
It'll be a
So it's an OE car.
A standard, yeah.
If it's an OE car, then yeah, you've got your choices of field. This is what technical standards are for. Technical standards are to basically remove the need for individually warranting every application. If something's been made to a technical standard that deals with an interface issue, like charging does with the plugs, then people warrant their equipment to charge vehicles which have been similarly designed to that standard. So the Prius plug-in hybrid will be a J1772 connector, so you can buy any J1772 station, and that's it. You don't have to go out and solve any more problem than that.
Yeah, but if the car that you buy is not a plug-in model, you're likely to run into warranty problems and stuff.
Well, I'm a little bit confused as to the line of the question, because I thought you just said that you weren't going to be converting the car. So if it's not a plug-in model, but you're not converting it,
on is what you need to go from a non-plug-in hybrid to a plug-in hybrid.
short of buying a different car.
It's not just a plug.
There's a lot of things. It's not simply a case of just putting the plug on.
No.
There's a lot of things to change,
and
it's not small beer. I wouldn't suggest. I mean, there's people here. I mean, Clint knows a lot about this stuff, but it's not small beer. Converting your car is something which you either get someone who really knows what they're doing to do it, or you learn about what's involved, and that means that it's going to be a new hobby. That's really the only way of looking at it. I wouldn't recommend undertaking it as a DIY project unless you were already a qualified electrician or electrical engineer, and you'll still need to have it certified to go on the road, which means that you'll still need an engineer's certificate to do that. There's a lot of people here who know a lot about this outside there. I'm not best advised to speak on it, but go and have a chat.
I think we're talking across purposes.
You're sort of basically, it's what we turned ourselves getting at Prius as well.
Yeah.
Is that the only way you can actually charge the batteries is by turning it on to petrol and driving the car around, and when you're driving it along, the battery gets charged. What we wanted was something that we could park in the garage, and with the Prius, you could say, and then just plug it into a power point and charge up the battery overnight, whatever.
That's still converting. I'm not.
It still is a conversion.
It's still converting. Yeah, absolutely.
It's significant conversion.
Yeah,
It is.
This is not
so it's
small
not
beer.
available. No kits available.
Oh, there will be kits available, but let the buyer beware. That would be what I'd say about that. Don't go charging into it. Pardon the pun, but don't think that's just a small task. And the car, I don't know what Ricardo said about when the plug-in Prius is going to be available in Australia, but I think taking that on, Cyro converted a few Priuses. There have been conversion kits available. If it's a latest generation Prius, I'm not sure there'll be that many conversion kits available, because the latest generation Prius is in a model family that has a plug-in equivalent, which means that there's not much market for a conversion kit, and they'd only be developed in the US because Australia there'd be negligible market for them. So it's a lot of engineering effort for
There are people
no
who
return.
do commercial conversions for a plug-in, to a plug-in press, but they're not cheap. You're talking $12,000.
Yeah, and you can't sell the car on like it's yours for life basically. There's no value in thinking of it as a 3 to 5 year ownership experience. It doesn't go like that.
They put extra batteries in as well, which makes the press very
we
worthwhile. And it becomes an electric car.
We ended up buying a Leaf.
Oh, there you go. Yeah, that was the easiest way to solve it, definitely.
Yeah.
Lady up the back.
Is there a danger with the fast charging that it's going to shorten the life of the battery?
Yes. Yep. The market's still figuring out how to value this. So second-hand vehicle market for plug-in vehicles at the moment is very uncertain. And but what will happen over time is that once it becomes easier to identify a car that has gone through a lot of fast charging episodes, then that car will be worth less than a car that is. And the nominal battery life of the car is 8 years. If you're fast charging all the time, it'll be less. So that says while people don't know what's going on, fast charge your car loads and then sell it before anyone realises. That's probably the way forwards right now, but that'll change. People will figure it out. And not only that, but the market's probably already decided that it'll pretend that all cars have been fast charged lots and just means that you've got no resale in the car anyway. So that's a problem, just an early market problem. Gentleman here.
Yes, what's your view on battery replacement technologies?
But as in battery swap,
Yes.
I think really we've seen that unfold. That story, Better Place played and lost. That's basically
Currently,
it.
Tesla has functions, and cars have functions to do that too.
Yeah. So
Elon Musk showed on the YouTube clip of how quick it is to swap.
yeah,
batteries.
Tesla are a really interesting case study because they're building their own proprietary network for their cars. So they have this supercharger network. The battery swap, to some extent, if you've got a supercharger network, I've got no idea why they would want to have a competing battery swap network. It's also quite a complicated engineering challenge to pull 300 kilogram object in and out of the car with all of the connectors that have all got to be tickety-boo in the space of 3 to 4 minutes, because that's about as long as you want to spend doing it, otherwise it's waste of time. So I don't know, I feel like that game's been played and lost by a Better Place. They had a chance, they blew $1 billion, and that's it. That's not going to happen now. So probably the quick charges is the way it's going to unfold.
But as the man said, there is a very good thing on YouTube on the Tesla battery swap.
Yeah.
And the big advantage is it takes 90 seconds.
Yeah.
Whereas you charge at a Tesla supercharger, it's free.
Yeah.
But if you have a battery swap, they'll charge you $15. Now, they've solved the engineering side because they use exactly the same equipment as in the factory.
Yeah.
It lowers the battery outputs in UNL robotically and tightens them to the original factory spec. So that side of it has been solved.
Yeah, I think, again, though, we sort of get into this issue to do with technical viability and financial market viability, and they're quite different things. So Better Place blew $1 billion on this particular idea, and Tesla are at their core a car company, not a charging company. So whether they will blow $1 billion on that idea all over again, a proprietary solution at that, I think it unlikely myself. They'll never raise the finance for it because Better Place played it all up for them. So they'll never be able to do it.
One of the short-term ways of getting around not having charging stations around our communities is making them truck-based, where you could have like a semi-trailer with the latest batteries and charging systems already there, and they can be rolled out onto our road network, and then people can go and charge them up, so they can be found anywhere we need them, and then of a night time they can be taken back to a base and charged on our low-cost electricity night rate. And so that in the interim we've built ourselves a semi-permanent type of portable charging system that can be utilised around communities and cities, and then as the infrastructure gets built up, then we can take them out to further on so they can be utilised, and when those batteries get worn out or new technology comes, we just replace the batteries and put them into a new technology and bring those trucks further out.
Again, I think this is an issue that's the difference between technical feasibility and viability and what's actually viable in an economic sense, because the storage cost of the battery. I mean, the amount of value you're adding onto this amount of electricity, ultimately, to charge your car at home is costing you $3. You're probably unlikely to pay more than $10 for a sort of emergency charging experience, maybe 20, maybe. It's not the likely number of times that that's going to get used for the cost of operating a system like that. It's just, you can't run it at a profit. It's just not possible to do, and that's the problem. It's not so much that it's not technically possible, because absolutely that's technically possible, what you said. It's just not financially viable. Gentleman there, and then...
I have a Mia, and I live out in the hills near Wheelsville, so I haven't seen a fast charging, so I haven't looked at that one before. It has the error code on. Does that mean it's not working? And can you explain how you actually operate and what it costs?
Well, you know, look, it's got the error code on it. That's usually a pretty giveaway sign, isn't it? So. Well, I assume so, but I've never seen one, so I don't know what that actually No. Well, look, I'm not sure, but I'd be very surprised if operating perfectly was called error. So probably not working. Yes.
If I was relying on it to charge it,
you'd be a little disappointed.
Yeah.
You have a charge for it.
Yeah, there's probably.
No, that's what I mean. I don't know how the system.
Oh, you have to have a charge.
How that one works in particular, I don't know. I'll have to go and have a look and see what's going on. Yeah, well, I have got a car to plug into it, so I'm not quite sure.
We've got the Nissan Leaf out here. My husband's giving rides on it.
Oh, okay.
For people at the moment. So if you want to have a ride, go and sign up at the disc up at the top in Yorkshire, and you can go out and have a ride with him.
Yeah,
and he was hoping to actually fast charge his car, give it a buzz before he hit it home.
Was there anyone from, Clint, do you know anything about this? Or?
I'll go down and take a look and see what gets sorted out.
Yeah.
Otherwise, we might be in the town. And he's a lizard.
So could someone explain how it works then?
How it works? So that's a three-phase power. So it is literally a piece of industrial equipment in many respects. So it takes three-phase power, unlike your home, which is single-phase. Probably you might have a three-phase home, and so it uses 415 volt supply. That particular unit is a 25 kilowatt peak power unit. Battery. I'm going to get a little bit technical here, but the guts of it is that batteries, being an electrochemical technology, they're not linear in behaviour, and so there's a variety of things about them. But basically, they have to be kept within a certain temperature range, and as they're charging, they will evolve. They will generate heat from within the battery, and so that has to be managed. And so the combination of the ambient temperature, the battery management system's response to it, and what it then tells the charging station dictates how quickly it will charge. Ballpark, you will charge about 50% the capacity of the battery in the middle range of the battery in the space of about 10 to 15 minutes. It won't charge any higher than about 80%. And that's because, again, the battery just doesn't like getting force-fed at that level of charge capacity, and so there's a lot more to it than that. I've really simplified it, but the guts of it is that it's not linear. It's sort of designed to be an insurance policy for you that you use occasionally. It wouldn't be the primary mode that you would charge the battery in, because the battery will degrade more quickly. That's the guts of it, I suppose. Yeah. This gentleman here.
What does the charging infrastructure look like right now, like for Victoria or even just Australia as a whole?
Yeah, it's a bit thin. Yeah. It was on an opportunity basis that was rolled out. I mean, there's not a lot of strategy behind it, because Swinburne, were on board because they've got a great electric vehicle research program here. They were doing a bit of a refurb of an area of the campus. And basically the dean, who's got the EV program, has a bit of weight in the university. He was able to make it happen. University of Melbourne, even Mariels didn't have that pool at University of Melbourne. They weren't doing any refurbs, so they got nothing. And that's not because it made more sense for it to be here versus University of Melbourne. They could have had one too, but they couldn't sort it out. And so what you see is basically chargers put in more or less where they would have them. So Moreland Council has a fast charger because there's a guy there, Stuart Nesbitt, who's just gung-ho and made it happen, versus City of Melbourne, who are, they have a lot on their plate. Let's just leave it at that. So, Yeah.
I drove down from Wangaratta this morning, and you can charge in Albury, Benalla, Seymour, and the fast charger at Moorland, which I did.
Yeah. So the stories behind these things, that initial report that I described, that one, that's got the whole story about this stuff in it. So if you want to know about how this works, then it tells you all about a lot of these things. So I don't know how the presentations will get distributed. Yeah, that's on the Vic Government website. So that's I've just made it a bit easier to write down if you're in a hurry. It's not really that easy because who the hell knows what that is? What letter is that? I think that's a lower J, lowercase, uppercase J, RM. Anyway, Felix will probably make these presos available through the ATA website. Yeah, okay, there you go. Presentation will be available through the ATA website. So if you want to...
Any more questions? Okay, thanks very much, Chris.
Okay, no worries.